Hello, everyone.
Hello.
We'll wait for a couple of minutes for more people to show up, okay? Just 2 minutes.
Okay.
Thank you. I believe we may start now. Today in topic 3, we are going to be speaking about shift register. There are many types of shift register. Shift register it can be serial in and serial out. One input and one output. It can be serial in and parallel out, like the one we are going to use today. The serial in and parallel out, I have, for example, 8. And as I input the first bit, it will go to the least significant bit. Then with the next clock, it will be moving until it reaches the output. After the 8th clock, all of my 8 bits will be ready to be shipped out. So this will be serial in and parallel out. There are shift register parallel in, parallel out. Today we are going to speak about this serial in, parallel out. It has many applications. We would need parallel communication because it is much faster. But with parallel communication, we have one drawback. That is, if we have the signal being traveling over long distances, not all the 8 bits may reach the destination simultaneously. So at the end, I may not get the correct data. That's why parallel transmission is limited to short distances. If I want to go long distances, I would go with serial transmission. In serial transmission, I am sending bit by bit. Now, with this serial transmission, it will be a little bit slow on the receiving end. If I have the CPU waiting to receive 1 byte, 8 bits, so it will wait for 8 clock cycles. That's why we are using this serial in, parallel in. We let the data be transferred by after 8 clock cycles. I am saying that I have my shift register ready and I can enable the output to go out and my CPU will grab all of it at once. This is one application. And let's see the handout you have. We are using here this shift register. As you can see, it has 8 output. So I am getting data in, this is the data, and clock, and the clock here, it is synchronizing my data transfer between my shift register and the outside world, and I have a latch. Whenever you enable this latch, that means the 8 bits will show up after enabling the latch. I can have my output connected to LEDs. In this case, I will see the zeros and ones that I'm expecting. The command we'll be using, it is digital write to write the data to my Arduino, to my shift register. Digital write enables writing the data, and you need, as you said, clock and latch at the end. This is the shift register 74HC595 that we'll be using. We have QA up to QH. Those will be my output. I have shift register clock and its inverse. We have, of course, VCC and ground. We have the output enable, that is low, active low. And let's see what's written here, QA to QH. Those are my output from the shift register. VCC, ground, shift right, and this will take the data pin, will take the data from data pin and shift it. The data will take the 8 serial inputs. And this is my clock, SR clock. And R clock, it is the latch. Whenever you are ready, you commit your data to the output pins of the shift register. We have also the shift register clear or output enable. Here, the output enable, it is active low as we said. That means if it is low, it is enabling my output. Let's see how we are gonna work with this. First of all, I have my latch. My latch here is low. This is the starting point. I have no data. I have the clock low. Now I am inputting my clock with the rising edge. The data will go, I can select going to the most significant bit or the least significant bit. I can select the starting and how the data will move. And my latch still low. So the data came in, and if we say that we are going to the most significant bit, I are going to go to 8. Then one more clock. I have the data that was in 8, now it went to 7, and a new data came in to 8. Please note, latch is still low. I keep on doing that, and when I finish, I can set the latch to be high. Now I have my data as I inputted them. High, low, high, low, high, low. This is the first data that we are going to send. The command that we'll be using, it is called shift out. Shift out, it takes this function, it takes data, clock, and here I'm specifying which bit will be my starting, the most significant bit first. And this is the number I want to see. I put here B, means binary. I want to see my LEDs high, low, high, low, high, low, or 0, 1, 0, 1, 0, 1. So in my program, I specify the data pin number, the clock number, and I am saying the order I'm going to specify, that the most significant bit, and the value that I will be shifting. This is the pin numbers that we may use for data: pin 8, latch, pin 9, clock, pin 1. This is the wiring diagram. Here each LED is connected through a resistor to limit the current. Now you will be writing the program, and the main command that we'll be using is this shift out. So first, I need to wire my circuit. Then in my program, I need to specify the 3 pins and use the shift out. Of course, before using the shift out, I need my latch to be low, and I need to send to this latch command a low signal. Then after using the shift out, I'm gonna use latch high. This is the first part. Then I believe here you may use the same structure for any other data. Here I used 0101. You can use it for any other data other than this one. But for now, we need the LEDs to be on, off, the 8 of them. Please read carefully, and I believe this should be very straightforward. Any questions? Before you go to your breakout rooms, please let me know if you have any inactive member in your group. I'll be passing by each group, and I want to know if there is any inactive member in the group who doesn't participate, who doesn't help at all. So please let me know, and I'll put him or I put her in a separate group.
Oh, wait, do you want us to tell us before or after we go into breakout rooms?
No, I'll come to each breakout room and I will asking you.
Okay, gotcha.
Okay. Now all rooms are open. You may go to your designated room. I left it open for you to select a room that corresponds to your group number. Hello,
Hello.
Hello, good evening.
I can see that Muhammad is not joining you.
That is correct. Yeah, he has
Yeah.
not been a part of our group at all. So
Yeah, unfortunately, we even since before we met last for class, I mean, like even since our last class session, we still have not been in contact with him. He has not returned any of our emails.
So he is not helping any in your assignments.
Correct.
Okay, no problem. How is the shift register going?
That's actually going pretty well, seeing as we more or less finished it late last week. And we're just doing the write-up now.
Okay.
So
Could you
we're
show me your circuit?
sure,
the-
I have mine up or available.
Okay.
Let's see. You want to see the hardware? Let me start video.
The hardware running, yes.
Yes. So here is here's the light writer. That's what I have the code on right now. I'm using the
Yeah.
shift register to do that. And then I
Yeah.
also have the ultrasonic sensors for that part of the assignment, but
This is not this part. This part is just to have 0101.
yeah, we're way past that.
Okay. Would you please share the code?
yes. Stop video, share screen. Here's the code that I'm using for setting the data.
Yeah.
I'm using that digital write for the latch and then shift out
Mm.
a most significant bit. I declare all my variables and everything for what pins I'm using.
Yeah.
For my light writer, I'm using for loops where I'm actually incrementing by the power of 2. So instead of having an array to that I'm discretely defining every address, excuse me, I'm just incrementing by power of 2.
Okay.
That way I can go as far as I want with my length of the address. So
Okay. And you have good comment statement. Thank you.
thank you.
Yep. So as you can see, it's going pretty well over here.
Hello, Daniel.
Hey.
Do you see your partner, Mike? Does he show up?
No, he's not here, and I haven't seen any emails from him, so I'm not sure what he's doing.
Okay, so I will remove him from your group.
Okay.
And what about our project tonight? The shift register?
I think it's going pretty good. I can show you
Yes,
what
please.
I've got. 1 second. Okay, so I've got this set up with the LEDs right now. And I've got the code for the first part. Right now it's set to display the number 2. So that's why this second LED is lit up.
Okay.
I'm gonna change it to, I'll do 5, how about? And we'll see what it displays there.
Okay, go ahead.
So that's 5.
Yes.
So you can see the 4 and the ones place is lit up. So that's the first part. I actually have this what is this? Sorry, hang on. It's the ultrasonic sensor here, which I've been working on. But this is the first part right now.
Could I see the code?
Sure. All right. I think I might be sharing the wrong one. Hang on. All right. Do you see code now?
Yeah, this is clear. And you are giving it the number to display.
Yeah. Basically, this right here determines what will be displayed and shifted out.
Yeah. Have you tried instead of most significant bit first, least significant bit first?
Yeah, I have tried that, and it'll flip it around. I could do it now. It makes it so actually the way this is wired up, I think it makes reading it a little easier because it'll be the ones place will be on the right.
Okay.
But yeah, it works.
Okay, great. Thank you, sir. Hello, Paul.
Hello.
Paul. How's it going?
It's going well. I'm still working on my void setup function, and I'm almost done with the setup, and then I'll write the loop.
Okay. But you can display one number now or not yet?
Not yet. I got the circuit set up, and I'm just writing the setup function right now.
Okay, go ahead. Thank you.
Thank you.
Hello, hello.
Oh, hello.
How's
Hello,
it going?
sir.
Lab 2 is done?
Topic 3 is done. We're just working on lab 2 right now.
Okay. Would you please read my announcements?
Sure, I'll take a look. Okay. Canvas. Announcements. Okay, you got reorganizing the groups in project 1. Let's see here. Okay, if that makes sense. And then project.
Yep.
You see to discuss it. Okay, gotcha.
So next week we have only 2 assignments. So I'll give you time to work on the project together.
Okay.
In addition, at the very beginning, I'll ask you to let me know about the idea you are going to implement in the project. We have many hardware, and I don't expect you to use all of those hardware, but at least use few of them in something that has that can show your skills.
We can definitely do that.
Okay. I'll leave you now to continue working on this lab assignment. And I believe that is all for tonight. If you are done, you may leave, or you can continue discussing about the project. Thank you.
Okay.
We'll do that. Thank you.
Bye-bye.
Thanks, sir. Bye.
Hello, Chelsea.
Hi,
How are you tonight?
I'm good.
Great. Are you done with lab 2?
Yeah, I think so.
Could you show me?
Sure. I made a bunch of different sequences because I wasn't really sure, like, are we supposed to just use the code that you provided to do the light rider?
Just show me what you have.
Okay. Okay, I'm not really sure. Sorry, I have like a laptop, so I
Okay.
kind of did a light writer like that. I adjusted the code a little.
Very nice. Excellent. Acceptable. Would you please read my announcement?
Oh, yes, for the project?
Yeah, no, there are 2 announcements.
Oh, okay. Oh, was that for the groups?
Yes, and second one for projects. Project 1.
Okay, yes. Okay.
Is it clear, Daniel?
I think so. I guess the project is somewhat up to us to decide what to do, right?
Yes, I need you to use, of course, not all the hardware that you have learned, but at least a few of them. And then all what I need to see is your skills in implementing this hardware in some software program that shows your skills. That's it. And the coming Tuesday, Monday, we have just 2 assignments. So I'm going to give you time to work on the project together. But at the very beginning, I want to see your idea, what you will be doing.
Okay.
And I believe that's all. And tonight you are done. But if you want to continue discussing what you will be doing as a project, you are welcome. But since you are done with the lab, that's all for tonight. Thank you,
Okay,
guys.
Thank you.
Thanks.
Hello, Paul.
Hello.
How is lab 2 going?
Good. I have the light writer working.
Could I see it?
Sure.
Yeah.
But it's working.
Excellent. Would you please read my announcement?
Sure.
Two announcements.
2 announcements. Okay. Okay, reorganize the groups.
This has nothing to do with you.
Okay.
Project. Project 1.
Okay, yeah, I'm reading that right now. Okay. So we just need to use some
we are going to have we have now many hardware that we used. I don't expect you to use all of them, but at least few of them that shows your skills. And next week we have only 2 assignments, so I'm going to give you time to work on the project as well. And at the very beginning, you are going to tell me about the idea that you are going to implement.
Okay.
That's at the very beginning. And then on Monday, February 13, you will be presenting your work.
Okay.
And as I said, those who do not attend, they must attend for this presentation.
Okay.
Thank you, sir.
All right. Thank you.
That's all for tonight. If you want to continue, you are welcome. If you want to leave, that's all for tonight. Thank you, sir. Bye-bye.
Okay. Thank you.